Hi, welcome to the vBrownbag session. I'm Andrea Mauro, VMware expert and Veeam Vanguard and VMCA. We are here to talk about how backup strategies should follow different type of storage architecture. So this is the agenda for this session. And we can start on how backup program can work with virtualization platform like, for example, VMware. In VMware, we have a specific API for storage data protection. And with this API, you can take a VM snapshot and use those data to have a backup completely agentless. And from this backup, you can just take the data and put on a target. The same API can provide incremental data transfer just to avoid to have a full backup at source each time. But mainly are just a common API for all the backup programs. But each backup vendor can then apply those different API in a different way. For Hyper-V is a little different because the VSS framework is used. VM snapshots are not so critical like in VMware, but the concepts are similar. You still have agentless backup possibility. From the storage side, probably most of you know this pyramid of different type of storage. The main question is if this pyramid is still true, because maybe the size is not completely true. There are storage appliance disk-based, not tape-based, that can store a lot of space, and cost can be very inexpensive also for some kind of spinning disk like SATA disk. Or if you're looking to the cost per IOPS or other metrics, is not truly correct that this pyramid is still valid. Mostly we are talking about different type of storage rather than a common pyramid, because we can have SSD or flash. We can have different type of disks. In this case, we see a fiber channel, but is an old schema. Let's say primary storage and tier 2 different type of slow disks, or in some cases tapes, and of course in tier 3 tapes, but also in this case something is changed because can be also cloud or the other kind of solution. The concept is that we can have different tier of storage, and we can move data for the backup from the primary to a secondary storage or to another type of storage. From this point of view, if we took, for example, Veeam can handle this kind of movement in several ways. The first, from primary to a secondary target, to a destination target, is simple, is the common way on how Veeam works. But you can have also a backup copy job where you can have different secondary target where you can put your data after that you have stored in your backup target. And other option can be stored on a tape, so tier 3, for example, or tier 2 if you don't have a real tier 2, but usually is tier 3, or replace tape or use as a different solution, cloud, as a backup target with the function introduced in Veeam 8, Veeam Backup and Recovery 8, where you can use a cloud provider as a target, a backup target. But going back to primary storage, we can have a different type of primary storage. Previously, we have talked mostly on how we can have secondary and third tier storage. But on primary, there are different classification on how storage can be built. This can work also on other tier, but mostly can be really interesting on primary storage, because we can have storage that are mainly dual controller storage in a typical cluster failover or primary and standby, or in some cases both active or active on different resources. And the type 1 is the mostly common type of storage because until now, because it was the classical centralized storage approach. This has evolved in the years with more complex centralized storage, where you can have more than 2 controllers, and you can scale those controllers, maybe limited to 4, 8, it depends. Mostly are active controllers, but it's still a centralized architecture. So type 1 and type 2 are centralized storage. And a new trend that has started some years ago is the trend where you can have multiple storage, multiple controllers, and you can aggregate all of them in a different way with loosely coupled cluster or some kind of configuration, logical configuration, or with some kind of distributed share nothing, where each node does not require something share with the other node. This is not completely true, because at least you need a network that must share across this kind of storage. But anyway, type 3 and type 4 are some kind of distributed storage that can truly scale out across the network, normally are IP based, and potentially both type 3 and type 4 can become a different type of storage called hyperconverged storage. But going back to centralized storage, because type 1, type 2, and also type 3 and 4 can act as some kind of logical centralized storage. For type 1, the schema is like this. You have mostly dual controller front end with potentially more than one interface on each controller, just to have availability or resiliency. We can have multiple type of front-end protocols, like fiber channel in this case, but also iSCSI or NFS, doesn't matter. And then we have a backend bus with all the physical disks. And in this case, when those kind of storage started, flash weren't so common or so convenient. To avoid the performance issue of physical spindle disk, a cache was be placed to just accelerate the front-end request on the back-end channel, on the back-end bus. For this kind of storage, you can have traditional approaches, and coming back to VMware, VDAP API provide some kind of feature. Mostly are, I can took my backup with a SAN direct access, or through a network, or through a virtual appliance. Are three different ways, are called in VMware transport way, that we can take our data from the source and save then to a target. For Veeam, all this kind of approach can be supported in different way, mainly, depending also on which kind of front-end protocols are we using. Because if we are using Fiber Channel, we can use a virtual appliance, network mode. Yes, we can, but mostly in Fiber Channel, people are using direct SAN access, where you can have a backup proxy on a physical system that is connected on the same fabric of the hosts. So the backup proxy acts as an host, like the other hypervisor host, and is able to take all the backup LAN-free. Is not completely true, because the backup server still need to send some commands through the network, but after this, all the data transfer is handled by the SAN, and in this way can be interesting to avoid congestion of the network, or to avoid to use a different network for the backup. Virtual appliance mode, that is sometimes called in VMware helper mode or network mode, can also be used, but are less common if you have Fiber Channel. But again, you can use it if you want. For iSCSI, if you are using iSCSI protocol, you can use exactly the same approach of Fiber Channel, because it's still some kind of block-based storage. Again, you can use virtual appliance mode or network transport mode. It depends on how is built your backup infrastructure, and how do you want to provide the transport of the data. For NFS, for sure, the direct SAN access mode is not supported, not through the standard API. You can use the virtual appliance, or you can use the network mode. It depends on your needs. Usually, the network mode has some issue, some performance issue if you are working with 1 giga Ethernet, but if you have a 10 giga Ethernet, can be probably the best solution, because compared to the virtual appliance, it does not spend the time to add all the VM disks to the virtual appliance proxy. That can take some time, and in network mode you can just avoid this. For local storage, of course, direct SAN is not supported. You can choose virtual appliance or network mode. It depends by your needs. Veeam can also use a different type of approach. It's called backup for storage from storage snapshot. In this way, you can use not the VM snapshot provided by VMware vSphere, that has some issue if you took a snapshot and you keep for too much time. But they are using the standard API to take the snapshot, so I have a freezed version of the virtual disks. But at this point, they are also using API provided at storage level to take a storage snapshot and then release after few seconds, few minutes, the VM snapshot. In this way, you still have the issue of VMware snapshot, but a VMware snapshot is just working for a few minutes. So the consolidation, or the correct name is the deletion of the snapshot, is really fast, and you don't have to worry about how big can become the snapshot. At storage level, snapshots are normally managed in a better way. So you can keep the snapshot for more time. You can have all the time that you need to take the snapshot and took the data from the snapshot. In this way, you still use the standard API, because if you want to be certified for VMware, you have to. But you can avoid most of the issue. From another side, this can bring new issue, because in this way, you can really have the fastest backup that you can, and potentially you can bring some performance issue at the storage level, because you can took the data as fast as you can, and maybe the storage can have some issue for the IOPS if it doesn't provide a truly quality of service of its operation. From this point of view, is really interesting that with Veeam, for example, you can have a storage I/O control where you can choose to slow down the backup operation if you see that the storage latency is growing more than a value that you can choose. So for centralized backup, mainly you can have different transport mode and different strategies, because if you have a supported storage and you can take the data from a storage snapshot, and maybe you can use the SAN transport mode, but it's not necessary. It depends by what you can use. You can have a truly fast backup, and with the backup I/O control, you can also avoid that this is so fast that can slow down your centralized storage. There is one consideration that we have to think about, because at host level we can have some kind of cache, so a cache host side. We can have two different type of cache, write-through cache that are mainly called read-only cache, or in some cases write-back caches. In this case, we are also optimizing the read and the write I/O, but this can bring a big backup issue, because your data can be not consistent at storage level, because if you took the data from the storage, or if you are using the API, in any case, you are working on the storage side. If data are not flushed from the cache to the storage, you can have some issue. From this point of view, depending on the type of the caching solution that you are using, there can be a specific knowledge base on how provide consistent backup also with this kind of cache. For example, for Pernix data, you have a specific workaround. You can use pre-process script to just flash the data and work in this way. Now with for VMware, with VAIO, that is a common framework, we can work with the API and make something a little better. But in any case, you have to consider this aspect if you have centralized storage and host cache solution. For Metro cluster, it just go fast, but potentially you can take the data from the secondary. It depends if it is active, or active primary, secondary. But you can take the data, the backup program can take the data from the the best storage depending on the queue of the request and so on. But again, you have to work on this or check compatibility for this. So this is just a recap. A backup server can be physical or virtual. It depends on which type of transport mode do you want to use. But remember that, for example, in Veeam, you can have multiple proxy. So your backup server can be virtual or physical, but your proxies can be physical or virtual. So you can choose the best strategy and not necessarily have to choose one and then cannot move to another. Now, in the last part, let's consider a different type of primary storage that is the hyperconverged solution. In an hyperconverged solution, you have compute combined with storage and potentially also combined with network. This kind of converged solution can be quite different, but the most interesting and the new trends, if you consider also the announce of Evo SDDC or past year Evo Rec, are on the hyperconverged class, where you can have a server in a cluster that combine both computing with the hypervisor part and both the storage. There are some reasons to do this. Is not necessarily the only solution, but is growing fast, and there are a lot of solutions in the hyperconverged area. But how backup can or should work with this kind of storage? Because one question can be, which kind of storage I have to use or should I use? Because in an hyperconverged solution, data are distributed in different nodes, and usually one data is replicated in more than one node. Potentially, you can choose the nodes that has the data locally, but maybe not the active data. So you can have some kind of backup that is more smart. And probably we should, most of the backup program can change considering this kind of storage and different type of strategy that you can choose on this. For this storage, the API can work mainly with virtual appliance or network because, of course, you don't have a truly direct SAN access. This is not completely true because potentially you can have, depending on the hyperconverged solution, you can have also local, a backup program that act local, but you don't have real benefits compared, for example, to access through the network or to a virtual appliance on this host the data directly. So backup server should be virtual? It depends. For Veeam, at least the backup proxy should be virtual if you want to use the virtual appliance mode. You can have a physical backup server and just use the network mode. One issue is that the API from VMware does not provide where the data are stored. And it's not only an issue of the backup API, but is an issue more general because vSphere actually does not expose where data reside in an hyperconverged solution that can be useful, for example, for HA or DRS to choose the best target depending on where the replicated data are stored. But again, if the framework or the API does not provide this kind of information, or at least not through standard API, does not mean that a backup program cannot be mostly aware or mostly optimized for this kind of storage. For example, Veeam has a direct support for Virtual SAN from VMware, and if Veeam is taking backup from Virtual SAN, it can choose the right node where a replicated data reside, and in this way you can grab all your data from the best possible nodes. Backup from storage snapshot can still be useful. In this case, no. In this case, you can use different strategies. Does not mean that, for example, some kind of hyperconverged solution can expose all the data through iSCSI or through standard protocols. Does not mean that is not possible. Actually, does not make much sense, but a backup program can use a specific API from the storage side or a specific function to take all this data, or maybe work on replicated data where you have a DR site or a metro cluster or something else. But is still possible to have some kind of optimized backup on hyperconverged solution. So with this, I finished. The message is, depending on the storage, you can have multiple choices. Some choices are not exclusive. And depending also on the optimization that you can have on the storage, the type of certification or knowledge base that you can have mixed between backup and storage, you can probably have better solution than other. Thank you very much.